As introduced, my name is Aleksander. I work at Scala, a consulting company, and I'm here to talk about duct tape. So yeah, let's start with an agenda. So first of all, I will go on a quick round about JSON APIs and how cool and not really boilerplate they are to create for us. I will then go on to talk about what is duct tape, what can it do, how we can help us in our problems, how we can leverage it, basically. I'll then go on to explain, like maybe not really explain, but introduce you to the idea of IDLs and codegen in general in Scala. And at the end, we'll just put all the above together for a nice example of this. All right, so let's start with the story. And the story is that moving JSON from socket A to socket B pays the bills, which is the harsh truth of software development, at least for me. Because when I wasn't a software developer, I thought it was fun and exciting, and it turned out to be buckety things instead. So yeah, that's, as I said, a harsh truth of software development, and it's also really, really mundane, right? I came up with a list of things that we need to do before we move on with our lives when we create a JSON API. So first of all, we have to create a root definition with a DSL of our choice. So that's your HTTPs, HTTP4s, things of the world, right? There's always some code right there. And then once we've done that, we actually need to model the request and response model of our definition, of the definition above, because there's always some things that come in and some things that come out, right? There needs to be a model. But then once we get the API model, we also probably want to somehow transform it to the domain model. So for things like bigger apps, you have a couple of layers of data, basically. So you got your ingest layer, the API model, the domain model itself that actually tells you all about the business domain that you work on, and creating the domain classes usually involves things like validation, parsing, sanitization, etc., what have you, really, right? So yeah, so there's a major amount of boilerplate right here, but then once we get that, we actually need to model the thing we just, document the thing we just created for other teams to actually use it. And then actually we just need to remember not to break it or redocument it once we introduce a change, basically, right? But yeah, once we've done that, we are free to apply the business source. So we can finally run our database queries, all the ones that we want. But yeah, as I said, there's a lot of things that can go wrong here. Like, not even wrong, it's just boring, and when there's boredom, there's like incorrectness sometimes, just due to laziness. And what if we actually have to do all that? What we only had to do those two things. What we only just documented the thing, and then we just did the business thing. Yeah, that's what the talk is all about. So the first thing that will help us in that is actually duct tape. So yeah, what is duct tape? Duct tape is a macro-based library for automatic and configurable transformations. What that means is, imagine you have two case classes. One of them is a person. A person may have a name and an age. The other one is also a person, maybe a person too, whatever. That also has a name and an age, but they're like the order of the fields is swapped. And yeah, so those two types are not the same in Scala, right? But what duct tape allows you to do is to have a one-liner that basically maps between those two representations for free. Yeah, and that might sound like Chimney to some of you. That's because duct tape is heavily inspired by Chimney. What Chimney is, for those that don't know, is a Scala library for boilerplate free and type-safe data transformations. So yeah, so given that duct tape is just a slightly different take on the ideas first presented in Chimney. The other thing that differentiates it from Chimney is that it's a Dota exclusive. What that means for me is I don't need to worry about Scala 2 anymore. I can just use the nicer macros. But yeah, that's it. Okay, so what is it made of? It's made of type classes, like one type class in particular. It's called transformer, as you can see here. A transformer has two type parameters, a source and a destination, and a single method. And it takes, and that method takes a single value of the source type and then spits out a value of the destination type. What that means for us is the transformation, quote unquote, here cannot fail at runtime. Basically, That's what it means to model, that it's always total, right? It cannot fail at runtime. The only place it can fail at is compile time. But if something fails at compile time, it's completely safe and cool for us to actually see, because then we will not crash our production environment. So yeah, as I said, transformer is the primitive that everything else is basically built out of in this library. There are instances for the most common transformations available out of the box. For example, things like transformations between collection types. For example, imagine you have a list of ints that you want to transform into a vector of ints. You can just do that for free. And there's also automatic derivation for case classes and enums, which is really the meat and potatoes of the whole Spiel library. Yeah, so let's see an example. So first things first, there's an import here. Just imagine that import is in every other example I show you here. But yeah, so there are two sets of case classes here, attack and a presenter, and attack2 and a presenter2. So attack has a name, a pitch, and a presenter, and the presenter itself has a name and a bio. And attack2 has all of the same things, just in a different order, doesn't really matter. So if you want to map between attack and attack2, you can just do this. You can say tag.tag2 to tag2. I messed up, never mind. But yeah, what is 2? Well, 2 is an extension method brought in by Chimney. What it does is it materializes a transformer and then immediately applies it. So to transform between those two types, I just say this. The transformer actually gets materialized, so we know that the transformation is possible at compile time. And the code that gets generated is just this, right? So it's just a primary constructor invocation on tag2, with all of the fields inside basically copied over from the source talk. Yeah, and there's also support for nested transformations that always just look like this. So there's no arbitrary instances of transformers, etc. It's like pretty much erased. Yeah, so like the general rule for case class transformations as follows. So the source case class needs to have all of the fields of the destination case class, name-wise I mean, and the types that correspond to those fields need to have an instance of transformer in scope. So yeah, as I said, there's also support for enums, only enums of build out of singletons right now. I'm now working on actually supporting proper ADTs, but yeah, that's what it is for now. So another example, we have two enums here. One of which is an event type that has two cases, on-site and online, and a second enum called conference type that has three cases, on-site, online, and hybrid. So once again, we can say event type on-site to conference type, and the thing that will be generated will be an if-else statement that matches on the type, but actually underneath it matches on the name, right? So when the name matches on the one side, the name from the other enum gets returned. So yeah, so that's what it does. And the general rules for the derivation of enums are just like, give me a sec, are just basically the same. It's kind of in the other way around, where the source enum needs to have a subset of cases of the destination enum. That's basically it. All right, so but more often than not, the models that we operate on do not match like one-to-one. So there can be like fields missing, maybe more fields have different types, etc. Right? So what can we do in this case? So another example, we have another pair of case classes. So now we have a person that has a first name and a last name, and a serious person that has a first name, a last name, and a SSN, which stands for a social security number. So yeah, when we try to, something's messed up here. No. So yeah, so when we try to transform a person into a serious person, we have a compile time error. The compiler user does that no field name SSN was from the person. So what can we actually do? Well, what we can do is we can configure, like nudge the transformation in some way so that it actually is statically possible. So there's another thing called into, which is kind of a transformation builder, let's call it. that is just like to, so you call it on the receiver, on the resource type, and then specify the destination type, and then you call the transform method. And the transform method takes in a list, maybe let's call it a list, of configuration options. So there are like, I believe 4 or 5 now, but like 3 of the most primitive ones I only listed here. So there's field.const, which sets a constant value to the to that field. So yeah, this thing here, so SSN, this picks the field from the destination type that we need to configure, quote unquote. And that thing actually specifies the value that we are seeing. There's also field.computed, which allows us to apply a function from the source type to the type of that field. And then there's field.renamed, which allows us to rename those 2 fields, which basically means that you take a value from another field, but you cannot apply a function to it. It's just a weaker version of computed. All right, so we know that works. So another case. So remember that the automatic derivation invokes the primary constructor, but it's not always possible for us to have access to the primary constructor, right? There can be cases where we have a lot of things that are hidden behind a primary a private constructor with maybe a smart constructor exposed underneath. So let's look at an example first. So once again, we have a person and a serious person, and the serious person now has a private constructor and also a smart constructor, which does some kind of validation. Doesn't really matter, right? So yeah, so in cases like this, we can use via. What is via? Via takes in a method reference, let's call it, and that method reference is then used in place of the primary constructor, right? So in this case, what will happen underneath is that we pass in the serious person.create method, right, to transform a person into a serious person. But once again, we have a no field name SSN funny person error at compile time. So what actually happens is the library is trying to match the fields of the source type, so person in this case, here into the arguments of that method. So it tries to find a match between first name and first name, which finds it. It matches last name and last name, but it cannot find SSN. So yeah, so we're back at square one basically. So what can we do now? So there's another combinator called into via, which is like into, but for method references basically, right? So we can once again nudge the transformation in some way. Just as with fields, we have our basic configuration options. There's arg.const, which sets a constant value to a given argument. Worth pointing out is that thing uses structural types, so you do get actual code completions in your IDE to complete those arguments. So yeah, moving on, there's arg.computed that once again applies the function from a source type to a given field, and then arg.renamed that quote unquote renames a name, right? All right, so there's one more case like that happens more often than not, is where a case class has maybe other case classes, maybe other data types that basically have private constructors, but they also have some kind of validations going on for them. So things that have constructors that return either or options or any other type. So is it possible to automate that? Once again, yes, it's possible. We just need to do some additional work, not much, but some. So yeah, another thing, enter variable transformers. And variable transformer is just like a transformer that can fail, as the name implies. And the only thing that differentiates it from the transformer is another type parameter, this time a higher-counted type of f, that basically is the wrapper type of a transformation, of a validation. So f can be option, it can be an either, whatever, right? So yeah, so to work with variable transformers, we can work with them in 2 ways. We can configure it that it does accumulating transformations. So accumulating transformations will, as the name implies once again, will accumulate the errors that happened between different calls, and fail fast transformation that will bail at the first site of trouble. So to do that, we use modes. And a mode, as I said, comes in two flavors, accumulating and fail fast. But a mode has another application here. It also gives us some information about the abstract type of f, some operations rather, that we need to actually create those transformations, right? So all modes have a pure method. A pure method is basically a method that wraps an arbitrary value into that wrapper type. So if f is option, you can imagine that pure just calls sum of that on that value, right? It has a map method that basically allows us to operate on the things inside the wrapper type. And then moving on to the accumulating mode, it has another method called product. What the product method does is it takes two values wrapped in f, right? So what is this supposed to mean is that we can easily treat those two values as independent transformations. Two transformations that can fail independently. What that means for us, we can run those in quote-unquote parallel mode, not really in parallel in the sense that another thread, just in parallel, which will allow us to accumulate the errors that happened when we were evaluating them. So that's how you get accumulating semantics. But then we also have fail fast with its flatmap method. And the flatmap method takes in a value that is already wrapped in f, right? So f of a, and then a function that goes from a to f, some f of b. What that means for us is that for each transformation in our flatmap chain, so each transformation in our flatmap chain is dependent on the values before it. So if one of the transformation fails, none of the other ones will be run, right? So that's how we get short-circuit semantics, so fail-fast semantics. So just what we need here. And then, let's look at a quick example. So once again, we're back to a person and a serious person, but this time with a twist. The serious person has a well-typed age and SSN. And the age thingy is a case class with a private constructor. It's basically a new type, but not really. It's just for like presentation purposes here. So it exposes, it has an instance of a fallible transformer in scope, which basically verifies if the value underneath is bigger than 0. If it's not, it gives you some kind of error message. If it is, it just wraps that in the private constructor, right? And there's also SSN, which doesn't expose fallible transformer. What it does expose is smart constructor and some kind of a different value, just for demonstration purposes. So as I said, to actually have a fallible transformation be run, we need to have a mode in scope. And a mode in scope means basically a mode in implicit scope. You can have it everywhere. You can have it by an import. You can have it in that specific file, whatever. It just needs to be there. Right here, I picked the accumulating mode for iders with a collection it needs to have a collection on the left side, any collection really. Now let's try actually transforming a person into a serious person. As you remember, we cannot just transform a person into a serious person because a person doesn't have the SSN field. That's the first thing, right? And the second thing is now the fields inside serious person are like quote-unquote new types. They have fallible things that have validation inside. So you cannot just put an either inside your constructor because it will not type check, right? So what can we do in this case? So once again we call into serious person, and then we call this thing that fallible, which basically puts our builder into the fallible state, which allows us to once again specify all of the configuration options from before. So we can specify all of the total configuration options. So field.const, field.computed, field.renamed here, they all work here. But it also allows us to specify some fallible variants of those configuration options. So, for example, there's a fallible variant of const called fallible const, which basically allows us to pass in a value that is wrapped in the wrapper type that is represented with that mode. Kind of contrived, but maybe you get it. So yeah, ssn.make, as you remember, returns either list of string or ssn, right? So we can just pass it in here. Likewise for valuable computed, but this time we use a value, we use a field from the source type. So we make an ssn from a name of the person. What it gets expanded into is something like this. So there's a lot of code at the top that we don't really care about. What we care about is this. So automatically derived valuable transformer for accumulating transformations is just a chain of product calls between all of the transformations that we defined. So as you can see here, we have a call to the ssn make thingy from here, which is the first argument of the product method. And then we have a call to the valuable transformer from h here, which was resolved for us automatically. All of that gets then followed by a map call to transform the things inside, because as you remember, the product method returns a tuple, which for multiple fields, that would mean we have a left associated tuple, I believe. So then the map method is used to decompose that tuple. It can be of any like arity here. The macro can take care of that for you. So we use that to decompose the tuple and actually invoke the primary constructor of serious person in this case. And the result type of that is either list of string serious person. All that generated for us for free, almost for free. So yeah, another example with the fail fast transformation mode. The transformation itself looks kind of different because now it's not a product chain call. It's a flat map chain call, basically. So we call flat map on each of the transformations. And then we follow that up with a map at the end to actually get the thing we want to transform into. So once again, that also returns either list of string or serious person, but the type kind of is kind of, lying here because it will not really show a list of string. It's just that I was too lazy to come up with an example that uses just a string here. I just reused the type I had at my hand. So what we get here is always a singleton list on the left, right? Because it will fail fast, basically. So yeah, now that we know what variable transformers are, we can move on to IDLs. So IDL stands for Interface Description Language, and an example IDL is OpenAPI. But when I'm talking about IDLs in general, OpenAPI is just an example here. Other examples include Smithy4S, for example, is a great example for Scala. OpenAPI is a YAML-based IDL for describing REST APIs. It's declarative and focused on a single thing. Yeah, it's focused on REST APIs only, I believe. It has codegen support probably for every possible language under the sun. If it has a compiler, it probably has a code generator for OpenAPI. It has great Scala support in the form of guardrail and is the source of truth for both implementers and consumers of our API. So let's quickly go through what makes OpenAPI definition. Basically, once again, that applies to all the other ideas that you probably know. So there's like, there's a thing that describes the path, in this case, /conferences, that takes in a post method, which means that it creates a new conference, takes in some kind of a request body that we'll look in a second. And then you've got your responses at the end. So we know that it can return with a 201 when everything is fine, or a 400 when the entity is invalid. And the actual thing from the request body looks like this. So it create conference is the request body of that endpoint, and it has like 3 properties: name, which is a string, datespan, which is a datespan, which is another object, and a city, which is a string. All of those fields are required. A datespan is just a start and an end. It doesn't really matter all that much. And validation errors, so the thing that gets returned in case we return a 400. So that's OpenAPI. And what does this really give us? Like, what does OpenAPI plus guardrail or maybe Smithy4S give us? So it usually generates the actual API model that we want, right? So that's the exact like copy from the specification that we just wrote. So that usually takes form of a case class. In this case, it's a case class create conference with the same fields that we specified. It also has some, it also generates encoders and decoders for our protocol of choice. My choice is JSON here. So it generates encoders and decoders for JSON. We've got a date span, and then we've got our validation errors, none that really matters. And then it also generates the really, really unfun part. So the hard work of, defining the root structure, the serialization logic, etc. And the responses as well. And then it also generates the actually useful part, because the thing that we really care about in this case, that's our like endpoint implementation, but with all of the protocol things really abstracted away for us, because it's just a trait that we need to implement at the end of the world, let's say, call it, to actually make use of that. So handler is a trait with an endpoint that we implement, but as you can see, we have access to the body argument, which is already deserialized. It's already a Scala object, so we're like pretty much at the end of the story here. We only need to do our like business things. But yeah, once we got that, how do we actually transform between the API model and the domain model? What can we do to like the sort of work that I mentioned earlier to make fallible transformation actually work for us? So we need to model our domains in a certain way, and by that I mean each field that has some kind of validation logic should be a new type. That's I think a general rule that is good for anything that we do here in Scala. But yeah, new types. What are new types? New types are basically like an abstraction on not always a primitive, but usually on a primitive like int or string, right? In this case, I created another abstraction, new type validated, which means we wrap around some kind of type that has some kind of validation. So here I use refined for my validation logic. So Scala 3 has that cool thingy called opaque types that basically lets us create a new type library in like 10 lines of code. So that refined thing and constraint thing comes from refined. It allows us to specify certain constraints on the data types at basically compile time. So yeah, so each of our new types will expose a smart constructor that basically materializes the constraint that we used in our type. And then we will have a nice error message at the end, right? And then from that smart constructor, we derive a fallible transformer. So each new type will have an instance of a fallible transformer in scope for free. So all the user has to do is provide a refined type that will describe the validation. And then let's see what will actually happen if we actually try to use that pattern. So we are trying to model a conference, right? So once again, a conference has a name, it has a date span, and it has a city. So that's what the case class would look like, and the insights of that would be insights of its companion object would have the unsurprising string thingy that is basically a type alias for a lot of validations from refined. So when I say unsurprising string with a size of something, I mean that this string is trimmed, it's not empty, and it has max size of something that we pass in here, right? So a name is just a new type over a string that has a max size of 20. It's trimmed, it's not empty. And city is basically the same, right? But then datespan is not a new type. It's just a regular case class that has a private constructor and that exposes a smart constructor that does, once again, some kind of validation. In this case, it just checks that the start local date is before the end date. And if it fails, you give some kind of error message. So yeah, putting all of that to work would look like this. So once again, we go back to our definition of the actual endpoint. So we will always create some kind of a class called conference rules in this case. that will take in some kind of service that we have. It's just basically a stand-in for your domain logic. In this case, it's just a conference repository that has a single method, and the whole domain logic here is just to put a conference in a database in this case. And then that also implements the handler of IO. IO comes from cat's effect. It's just the effect type of choice for me. So we put in our transformation mode in scope here, because we will be using the variable transformers with accumulating transformations in this case. And then we go on to implement the create conference method. Once again, we get access to the already deserialized body that we can just use for business logic purposes. So the thing that we basically need to do is to transform that create conference thingy into the domain conference thingy, and then call the conference repo that create method on it. And that's it. That's the whole domain logic here. So to do that, we'll once again call into on the body. We'll try to transform that into a conference, into the domain conference, right? We will do it fallibly because you remember we have newtypes there. So all of the fields from that are able to be derived automatically. The only thing that we need to help it to derive is datespan, because datespan doesn't expose a fallible transformer or anything. So we just do field.fallible computed. We pick the datespan field and then just invoke the datespan constructor on the thing from the API, basically by using via. We don't have to use via, but you know. We then map all of the validation errors to a 400 response. And then at the end, we just do the business logic thingy of creating a conference in a database. So does it actually work? I don't have a live demo because they never work. Sorry. But yeah, if I were to start up a server with all the things that we created just a couple of minutes ago, and then create a call request to the endpoint we just created with some kind of JSON body that has a name inside, and that name is over 20 chars, and that has a datespan that is not before the end, and a city that is also over 20 chars. That's what we get as a response. So we get all of the errors accumulated for us for free, which is exactly what we want. And then for a goodbye request that actually abides by the rules, we'll get a 201. And that's basically it. So if you like the library for your box criticisms and ideas here, for the code samples and alternative versions of that, so for example, a Smithy Forest version of what I just wrote here is available here. And that's it. Thank you.